In the last video, we went through areas of parallelograms and rhombuses and rectangles, and let's talk about triangles now. I'm first just going to draw this triangle, and then I will explain why the area is what it is. So we're going to take a triangle, a right triangle, with a base of 5 and a height of 4. I'll put the little right triangle mark here. Base of 5 units, height of 4 units. Could be centimeters, could be inches. And this area is going to be 1/2 base times height. You don't actually need the parentheses, but I like the way it looks with that in there. And let's solve this first. So that is 1/2 of 5 times 4, which 5 times 4 is 20, times 1/2 is 10 units squared. So here's why. Let's draw a rectangle that's also 5 by 4. And we've learned in the past that a rectangle, well, that's not right, that a rectangle has an area of base times height, sometimes called length times width. And a triangle, a right triangle specifically, is just that cut in half. It's half of base times height, or half of length times width. Well, what about triangles that are shaped without a right angle, an acute triangle, or an obtuse triangle? Well, let's do this first. We're going to make a triangle here, base of 5, height of 4, and I'm going to draw a line that is perpendicular to the base from its vertex, or to its vertex, which is just a fancy word for corner. Well, this is also going to be 1/2 base times height, and this is why we use base times height and not length times width, because we don't care about these sides, just the base and the height. And I can show you this, that if I duplicate this and spin it around, and hopefully not change its size too much, that we just get a parallelogram. And we found in the last video that parallelograms are just rectangles shifted over. So just like a rectangle is base times height, a parallelogram is base times height, and a triangle is half that. Let's do one more triangle. We'll make a kind of a crazy one here. And I'm going to do base of 5. And let's make this all the way, well, that's way out of the way. There we go. And as long as I have the height as perpendicular to the base from its vertex, these all have the exact same area of 10 units squared.